I need the hardware that is system.
Well, oh yes, they're there. Well, we're not uploading anything now, so.
There's one presentation missing. Oh, sorry. Did you want to say that? I'll move this.
I don't mind.
There's one presentation missing from this list.
Well,
I don't know whether there is a cutoff or something. I might explain why. So we had to switch to my laptop.
okay,
It's a very short 5-minute thing.
fine.
So
Yeah,
it's
that's
not,
fine.
it's not a big problem. Okay, shall I get things going? Oh, hi. Thanks. See you after.
Right.
Okay, good morning, everybody. Welcome to CFRG at IETF 104. If you could finish up your conversations and take your seats quickly, that'd be appreciated. We're already a few minutes behind schedule. The blue sheets are circulating. Please sign your name and give your affiliation, as usual. We'll collect them at the end. We had someone volunteer to take minutes for us. Is he here? Robin? Is Robin Wilton here? I guess he's not. I guess he's forgotten. Oh, he is there. Okay, Robin, you okay still? Thank you. We need someone to monitor Jabber.
Okay.
Oh, we've got Jonathan's going to do that for us. Rich, you're redundant. Thank you very much. You can back up if Jonathan doesn't do a great job. Thank you. So we're going to start, I think, with the chair slides. How does that work? Right. Do you want to do these? Okay. So Alexi's going to present these.
Right. So, quick agenda bash. We don't have lots of time, and I'm sorry, it's probably my fault. I didn't request enough, but we can request more time next time. So, quick status update, randomness improvement. Yeah, we'll try not to expand too much into the lunch. So, any agenda bashing? No. So, note well, you must have seen it several times this week or at previous IETF meetings. We'll take care of this. So you might have noticed Kenny has an affiliation change and new email address. So we will fix CFRG chairs to go to a new email address for Kenny. But in the meantime, if you're emailing us directly, take care of the new email address. We don't have, so document status. No new RFCs since Bangkok, but there are a couple in RFC editor's queue, and actually one is just about to be done. Hash signatures. GCM SIV is also being edited, so it's getting very close. A rekeying document is in ISG conflict review for first ISG session in April. So hopefully this will progress to RFC editor's queue very shortly. We have a couple of documents which, one for Kenny and one for myself, we need to follow up on. They might need revisions from editors, but we'll have a look. And then we'll submit them to IRSG for review. We have quite a lot of active documents, PRF, hash to curve, randomness improvement. We have one new document, Kangaroo 12, which was adopted by the working group very recently, as well as XChacha document. And in the related work, there is one document from Richard Barnes that will be presented today. So chairs are very slowly starting discussions on pack selection. We're going to have a presentation today on this to kickstart it, and we'll see how it goes. And with that, we have the first presentation. So I know what it is. Okay, I've done this. So they're actually in the right order, right? Cool. This is, yes, this is rather small. How am I going to? Control L. No, this is like a special. Still have to. It's good enough. It probably it should. Hold on. Right. No, it's.
Good morning, Stanislav Mishlev, CryptoPro, and together with Kes Kramers, Luke Garrett, Nick Sullivan, Christopher Wood, and Lilia Akhmedzyanova, I'm presenting a status update of randomness improvements for security protocols document. So, a brief overview of the document. Since all security mechanisms rely on randomness, and PRNGs can be flawed, can be backdoored, they can have some bugs. So, it's better to have a safety net to deal with these potential problems. And the entropy problems are really difficult to detect, so it's really good to have some kind of safety net. And a solution to improve any call of entropy and provide such a safety net is proposed in our document. The construction is on the slide. We had two minor changes, one about security considerations, about usage of this key that should be separate key, and some minor change in the terms. Nothing really great. But we had two major steps forward, one about the experimental results, and the second is about security assessment. So about experimental results. Thanks to Christopher Wood, now we have a very good document about experiments without construction. So the experiments were conducted for HKDF and CKDF. They were conducted in the conditions when the signature was calculated once, and then the construction was used in a loop. And an overhead compared to the basic CSPRNG was measured. So this is a pseudocode of what was done. And we did this for typical lengths of output randomness that are typical and convenient for such protocols as TLS. So these pictures are presented in the ePrint paper as an appendix, so we can look at them closely. But to be sure, for all four variants of lengths, it can be seen that starting from about 1,000 of loops, everything comes to an asymptote, and CKDF and HKDF works pretty the same, so there's no sense to get rid of HKDF. The cost is from nanoseconds to microseconds, so it's minor with respect to TLS operations. So we had these experiments added to the appendix, and to sum up, we don't think that anything has to be changed in the construction because of experimental results. We think that everything's fine with the construction regarding the performance. So keep it as it is. The second major step forward was with security assessment. Last time in Bangkok, I said that we had a security assessment published in ePrint, but it had some minor problems with assumptions. So the assumptions for basic mechanisms were questionable in some sense. So we promised to improve this, and we've had it improved. Now the updated version is at ePrint. Now we have a very good and complete security proof for all three desired properties. But with adversary who can read the output of basic CSPRNG, but cannot control this. For the adversary that can control the CSPRNG, the security proof also has some questionable assumptions. It's made in a random oracle model. So to address this issue, we understood that if we can swap the inputs of the extract function, we can deal with this issue too. So we can strengthen the proof if we swap the inputs, and nothing else gets worse. So we can deal with HMAC not as a random oracle, but it's in a most honest model. So we really can do better. And so in the paper, we've now have a security proof even for this case. So for case of swapping the inputs of extract function, we've proven that nothing else gets worse, and this property gets really better. Moreover, this change also helps to increase performance. So in this case, we can not only cache the signature output, but also the intermediate value of HMAC calculation after going through key values, K plus iPad and KXOR OPAD. So it's even better. But of course, we still need to revise this because it was quite recently. And so this seems to be only one question left, that question about swapping the inputs. And we think that we'll deal with this really soon. And after that, we'll ready to go to the research group last call. I think that we could do this before May. So that's all. Thank you. Questions, considerations?
Thank you, Stanislav. Any questions for Stanislav on this draft? Okay. Any on the Jabber? No? Okay. Last call for questions or comments. Okay, done. Thank you very much, Stanislav, for driving this forward. Thank you. Okay, next up we have Hotek. Hotek Wee is going to talk about the BLS signature scheme. Thank you.
Hi, so I'll be talking about BLS signatures. I'm Hotek Wee, and this is a draft in co-authored with Dan Bonnet, Sergei Gorbanov, and Chengfei Chang. So BLS signatures are signatures that relies on pairing-friendly curves. These are very efficient signatures. The public key and the signature are essentially one group element each. Think about that as something like 50 to 100 bytes. Signing and verification in the order of milliseconds. What really distinguishes BL signatures is that they are aggregatable in the following sense. You have n signatures from n public keys and on n messages. You can compress this n signatures into a single signature that still satisfy basically all n people have signed the n messages. So there are many applications we have in mind for BL signatures. One, probably in the context of IETF in particular, is that we can hope to use BL signatures to compress signature chains in public key infrastructures or in the secure BGP protocol. Another one that comes up quite a lot recently is in major blockchain projects. We want to use BLS signatures and the ability to aggregate signatures to reduce the bandwidth and storage requirements in blockchains. In fact, in the past year or so, the major blockchain projects like Algorand, Ethereum, Zcash, Achia have been sort of looking into providing have been working to provide production-ready and very efficient open source implementation of these BL signatures. So we expect to see deployment of these signature schemes in the next half a year or year. And so this seems like a very good time to get feedback from the community on the signature schemes and to try to standardize these signature schemes. In particular, many of these different signatures, many of the existing implementations actually use slightly different underlying algorithms. So we would like to have some standard on this. Right, so there are two related drafts on this topic, which our draft builds on. One is a draft for pairing-friendly curves. Another is a draft on hashing onto curves. So the signature scheme require pairing-friendly curves and also requires the ability to hash onto curves. So these are things that we will require. So, right, so I want to take this opportunity to sort of highlight some of the issues that comes up in BLS signatures, something that we'll address in our next iteration, and also to take this opportunity to get some feedback from the community about this. So the first issue is that the basic BL signature scheme is actually susceptible to a so-called root key attacks. What this means is that if I'm an evil user, I can register a public key that's correlated with the public keys of every individual in this room, and then later on produce a forged aggregated signature, saying, for instance, that everybody supports the adoption of our draft, even though none of you has actually ever signed such a message supporting adoption of this draft. So this is a security issue. Fortunately, we already know several mechanisms to handle this security issue. The simplest of which is basically when you are using the basic BLS signature scheme, instead of just signing the message, you sign a concatenation of the public key and the message. Another mechanism is that when users register their public keys, they provide a so-called proof of possession. So the simplest way to instantiate this, for instance, is that we require that when users register public keys, they also provide a signature on the public key. A third mechanism is to modify the basic BLS verification algorithm for verifying aggregate signatures, so that instead of just multiplying the public keys together, you actually take some carefully chosen linear combination of the public keys. So each of these three different mechanisms have different trade-offs, and depending on the use cases, you may want to use different ones. So one thing we want to get feedback on is the use cases people may have in mind, and sort of which of these mechanisms should we adopt, and to how much detail should we be specifying these mechanisms in our draft. The other is the issue of cipher suites. What this means, of course, is what are the curves we're going to use for our for the BL signature scheme. So most of the major implementations right now use BLS 12381. This is one of the curves that's already included in the pairing-friendly draft that I mentioned earlier. So this is certainly something that we want to support. But which other curves do we want to support? Also, in addition, the signature scheme uses the algorithm to hash on the curve. So which kind of hashing algorithms do we want to support? So a couple of them have already been laid out in the draft. And then there are other mechanisms, for instance, the most naive and simplest one, which is basically what's called try and increment in the draft, or better named as some kind of a hash and test. And then finally, we want to feedback on serialization issues. So we have group elements, how do we want to represent them as bits on the wire? All right, so let me say that we have a GitHub account. This GitHub account hosts both our draft and the draft I mentioned earlier on pairing-based curves, and we'll be very happy to get feedback right now. And also, if you have additional feedback later, you should definitely feel free to raise issues on the GitHub. Yeah, thank you.
Thank you very much, Hotek. Questions, comments from the floor? I see Ben approaching the mic.
Ben Kaduk. So for the rogue public key question, from an engineering point of view, it's typically best for us if there is just one chosen option and we don't have choices we have to choose between. And of those three, just off the top of my head, the first one where you sign the concatenation of the public key and the message seems the most robust in that all the participants can easily confirm that it was done. When you have to, option 2, you would have to trust that, the thing that's taking the registrations actually does this. And I didn't quite catch all of what 3 was, but I found maybe it included like a random linear combination of the keys. Yeah, so that's a little bit more complicated as well.
Right, so we agree. We do believe also that the first mechanism is the most robust, and in fact, it solves the problem in most use cases. The main drawback of the first, the situation for which the first mechanism isn't so desirable is in a situation where you have many users signing the same message. So in that case, when you sign the concatenation of the public key and the message, this actually incurs additional costs for aggregated verification. So one thing we'd like feedback on is what kind of use cases do people have in mind? Are there many settings where people do want to sign this? You have a group of people signing the same message? And in that case, we'd like to understand what the use case is like. And for that case, you really have to use either the second or the third. And we'd like to know for those use cases, which of the two will be more applicable.
Watson Ladd, 2 is not going to work for any sort of, 2 will not work for any sort of blockchain. There's no way you can control the public keys that people are giving money to, for instance. There's just no control. I think if you use 1, you can also use 3. Why not have 1 and 3 together if 3 is cheap?
Right. Okay. So there are several questions in there. Let me address the last one first. Tree isn't completely cheap because you need these extra exponentiations. And in general, what happens is that the way you do this exponentiation, you need to see all of the public keys that you want to aggregate first before you hash the collection of all of these public keys and then choose these exponents. So you don't have this ability to incrementally aggregate, in addition to the additional cost of doing this verification. So 3 is not exactly cheap. Certainly one can imagine doing 2 and 3 at the same time. Let me first say that I agree there are some use cases where 2 is not an option. For instance, if you are trying to, for instance, sign transactions on blockchains, you really want to be able to have transactions even before people register their public keys. For that, I agree 2 is not so applicable. But in the transaction setting, you're really signing different messages. So for that case, we believe that 1 is probably the best scenario. And then there are some other use cases for blockchains for which we believe 2 is applicable. But maybe I prefer to take that offline, but if it comes up again, I'll be happy to talk about that.
Hi, Nick Sullivan. Just as a reminder for your hashing into curves section, there is a draft currently at CFRG, and the latest version of the draft includes methods for hashing to super singular pairing friendly curves. So hopefully that can be of use as a cipher suite for, as part of a cipher suite for this draft, if you were willing to take it.
Yes. So definitely. The current draft, however, doesn't quite formalize try and increment. So it does talk about it, but not in too much detail. So one thing we'd like to know is whether there's a need to also include try and increment in addition to the other hashing algorithms that are already in the current draft. So that's one of the things that we want to understand.
So Hotek, I think it'd be good if you got together with the authors of the hash to curve draft. One of them is here. And hash this one out and see if you can...
We can speak about that, but yeah, we have try and increment defined vaguely, but as it's not constant time, we did not include it. Right. So if there's specific use cases that are not dependent on constant time, then we'd like to hear that because it could be useful to include in the draft.
Thank you. I think we'll close the line on this one. So last comment and question.
Since you were asking about use cases...
Can you state your name, please?
Christian Grothoff. One use case that I wanted to bring up that wasn't related to group signatures is blinding. With BLS signatures, you can also blind the public key and blind the signature. That's a use case that I would be interested in. So if that's in scope for you, that would be interesting to also have, in particular, standardized serialized formats and these kind of things for the blinding case that you can do with BLS signatures. Thank you.
Okay, that'd be great. Maybe if you could follow up with me at the end of the session or on the GitHub, that would be really helpful.
Okay. The chairs would like to assess the interest level of the research group in adopting this work as a formal draft of the formal document for the research group. So maybe can we have a quick show of hands of those who think it'd be a good idea for the research group to adopt this work? Okay, thank you. Are there any people who think it's a bad idea? Are there people who are willing to work on this and review drafts? Maybe a quick show of hands. 1, 2, a few? Oh, great, quite a few. Okay, good, thank you. We'll obviously take it to the list for formal ratification. But thanks everyone for their inputs, and thank you, Hotek. Okay, next up we have Richard Barnes, who's going to talk about hybrid public key encryption.
Hi, everyone. So this is a draft that was posted to the list a little while ago. I would kind of like to summarize, get some discussion in the group and see if this is worth adopting. So the use case here, the kind of history here is we had a few IETF working groups that had a need for a kind of encrypt to public key primitive. This came up in MLS, the message layer security working group, where we're kind of building a multi-cam out of a base cam. We needed kind of a way to encrypt to public keys in that context. It also came up in the ESNI context, the TLS encrypted SNI discussion, where you want to encrypt the server name indication field to the holder of some private key. John Mattson pointed on the list there might be some 5G cases. And one thing Karthik pointed out as we were working on this is that there's some existing software libraries that provide ESNI-like primitives that could, provide ECIES-like primitives that could benefit from some further review and a more standard approach, and especially around some of the extended use cases and usage patterns that these libraries see. So what had been done in the MLS and ESNI context is we kind of invented some ad hoc ECIES-like constructs, not really using the older stuff, the several standards that already exist, because of some of these deficiencies that have been discussed on the list. A lot of these existing standards are tied to old primitives, there's not test vectors, and there's not coverage for some of the use cases we see in deployment of some of these libraries. So overall, the objectives of this work are kind of to cover the use cases I've mentioned. So we need to kind of provide a primitive, a construct that can be used for encrypting to a public key in the MLS and in the ESNI cases and other stuff that has generally the same shape. And to do so in a way that we can have some formal verification and proofs around, and with the usual level of kind of IETF, IRTF agility with regard to the underlying primitives, so that we don't end up nailed to something that will be an old stale primitive in a few years. In particular, one of the interesting possibilities here that again was discussed in the list some is that if we can kind of take this and generalize from the traditional DH or ECIES sort of context and where you're kind of depending on a DH group as your underlying primitive, if we can generalize from that to something that uses a generalized chem as the underlying primitive, then we could end up with a public key encryption scheme that could scale forward to post-quantum algorithms better, because those tend to be more chem-oriented than DH-like. So the proposal here that's in the doc, can you scroll me up to get on the screen? Yeah, so I mean, the proposal here, it got a little complicated in 0.1, but the basic idea is to take a chem for the public key part and an AEAD for the encryption part, and use that to build up a public key encryption. So very much like not trying to introduce any magic here. The base case is really basically ECIES with clearly defined, here's how you derive the keys, how you apply HKDF to do the right thing. That's mostly where the interesting stuff is how the elements get combined together to derive the intermediate values, the keys and nonces you use. Because it seemed useful in some of these cases, we added PSK and what I call authenticated modes, auth mode, where the originator, the creator of the objects, the person who's doing the encryption, can authenticate that they possess either the private key of an asymmetric key pair or a pre-shared symmetric key. That asymmetric case is pretty widely deployed right now in the NACL context. With this box API, which provides this, I think the phrase that gets used there is sign encryption. I've also heard the phrase designated verifier signature in terms of the recipient being the only person who can verify the signature. But that sort of authentication, which is fairly widely deployed. The PSK mode seemed like a kind of natural analog that would likely have similar use cases. Finally, the last bit of innovation here is one of the situations you see frequently in uses of NACL is people wanting to do what is effectively a streaming mode of encryption. So you normally think of something like ECIES as doing an object encryption where you're going to encrypt a thing, but people wanted to kind of have an indefinite length encryption and be able to use multiple AEAD invocations off of one key encapsulation public key interaction. And so we've gone ahead and defined that in draft 01, a way you can set up a context, a single key from which a nonce stream emanates, and use that key and stream of nonces together to do multiple AEAD invocations based on a single public key interaction. So you kind of amortize the cost of the public key interaction over multiple AEAD encryptions. So that's kind of the overview of what's in the draft and what we kind of like to get firmed up and specified and vetted and reviewed, et cetera, if we were going to do the work in the research group here. So yeah, that's kind of what we've got here. We posted 0.0 back in January, had some really positive list discussion and some good suggestions. I think that the strongest note we had in that discussion was folks were interested in moving toward a chem construction. I think the first draft we had was more DH oriented, and folks thought that chem would be an interesting approach. So in 01, we did convert to that chem-oriented approach and added all these other modes. I mean, I think we'd be interested in feedback about whether folks think these kind of advanced modes, where the various modes are useful, whether the streaming stuff is useful. I think that would be a useful scoping discussion to have as we discuss whether this makes sense for the research group. But I'm hoping we can the research group will be interested here. I'll admit there's a little bit of shipping pressure, right? Because as I said at the beginning, there's working groups who need something like this, and they're trying to get their protocols done. I think we'd be looking to get this done in fairly short order. So, yeah, so there's active energy to contribute to this and get some good work done. And I'll also pause here and insert a thanks for the several people who've helped with this. Chris Wood and Benjamin Verduche in particular provided a whole bunch of good comments in addition to the folks who helped out on this. So that's all I have for now. I'm happy to take questions or comments, expressions of interest, et cetera. Thanks.
Thank you, Richard. So please come to the mic if you'd like to ask questions or make comments on this document, on the presentation.
Stanislas Mashlev. Just a quick comment that I really support this work, and I think that it will be good if it will be adopted in CFRG, and I'll be happy to help with this work. I think it's really important.
Thank you.
Eric Scrolla. It's good to see this done. Obviously, we do have uses for this. I think my instinct, maybe this is just the standards versus the research situation, but like you seem to be adding a lot of features that's not clear anybody needs. So I think I would be kind of more voting to keep it simple, but you know, maybe the chairs think that like the research group is a wider scope than what needs to be standardized immediately. So, but I have no uses for anything other than basically the thing in 0, 0. So.
Yeah, I think Karthik and I have kind of gone back and forth on this. We kind of staked out two ends of the spectrum in 0, 0 and 0, 1. Like, here's the minimal version, here's the maximal version. We're happy to like negotiate what.
I mean, in particular, streaming seems like, you know, now we're entering S-MIME territory, right?
So I had a question about streaming actually. So what's your security target there? Are you trying to give guarantees about the order of the chunks in the stream or the totality of the stream, or you know, where are you going to draw the line in terms of security? Because it's kind of a complicated topic, right?
Would my co-author like to step to the mic? So I will say what is in the draft right now says that the application is responsible for assuring the ordering, right. For us, ensuring things show up in the right order. Mm-hmm. I think things would fail if things get out of order, but I'm not sure like what exact properties we have around that. So Karthik?
Right, Karthik Bhargavan, Indri, I'm a co-author on this draft. So we called it streaming because somebody mentioned that keyword in the discussion. But really, this is, I would say, repeated use of the chemmed key over in AAD. And the fact that, and we have hard-coded a counter, so you can distinguish between different plain text, but we don't really think of that as necessarily achieving an STAE or some such definition right now. Just it's individual packets, but there are many packets that could be encrypted. Now, yes, there might be. You could go further or less. So.
Okay. Yeah. So just to clarify, it's really a shorthand way of saying we want to reuse the public key component over multiple.
That's exactly right.
Absolutely.
So
without any guarantees about order or.
Yeah, there's no assurance with regard to the totality of things you've done with this.
I mean, you can obviously build those things in, but using associated data or nonces or whatever. But then it ends up being a more complex construction.
That's right. Yeah. So what we are focused on in the current draft is to make sure that there is enough places where you can add information and context both during the encapsulation phase and during the AED phase, on top of which you could then build in a bunch of these things, including ordering, reliability, end of stream kind of messages and so on. But we don't think that is part of this this document. What we would observe is that it looks like most people who use APIs like Salt in practice, the box construction actually use this kind of API where they use one asymmetric construction, many symmetric ones.
Okay, thank you. So we've had a couple of expressions of support and interest in working on this. Maybe, again, it's worth taking a show of hands. So we'll ask the room if you please stick your hand in the air if you think it's a good idea for the research group to adopt this. Okay, I see a lot of hands up. Any people who think it would be a bad idea for the research group to adopt this? Okay, I don't see any. And we had a couple of offers of support to work on it. Any additional people in the room willing to work on this and help push it forward? I see a couple of hands. That's fantastic. 3, 4, 5. Excellent. Good. Okay. Thank you. Obviously, we'll have to go to the mailing list to ratify any call for adoption. But that's a good direction so far. Thank you very much, Richard.
Thank you.
Great. Switch now. Is this one? Yeah. We're just dealing with some presentational issues, as you can see. We'll be right with you.
Okay, so I'm glad it's not me in control of the clicking and making mistakes, right? So my first IETF, this is not an intelligent presentation. This is a presentation to try and draw the intelligence out of you to have you apply for the next generation internet funding grants. So if you can slide up. This is a call for you to work on the future of the internet, the next generation internet. There's a European Union open calls that are available at the moment that can fund you to work on various programs. Okay, and so this initially started with NONet Foundation and Gartner working on a report for the European Commission to create a vision for what the next generation internet would be and to create an internet of human values. So this was a consultation process that solicited a wide array of people, including the IETF at one point in time, created some draft topics, went through to this topic analysis, and at the moment we're in this pre-NGI phase. You can't really see this graphic because of image compression, but we're currently giving some money available that will flow onto a larger flagship project later on. And so part of the ecosystem that was consulted is these groups, including GÉANT. GÉANT is the Association of Research Networks in Europe. That's who I work for. We lead one of the consortia in this NGI space at the moment, out of 4 projects that are currently running. But a lot of people were consulted, and we need all of your assistance in developing what will be the next generation. So it's built on infrastructure as well as has some pillars in order to create this this next generation internet. And actually for the crypto forum, if you're building pillars and you're doing it with poor underlying foundations, then you're going to have problems at some point in time. So if you have a look, one of the things that came out of the study was engineering trustworthiness. And one of the experts interviewed said that we need trust built from the ground up. And so this requires the reevaluation of the complete stack that forms the internet as we know it. So these were actually the topic areas that were identified as part of the study. This doesn't directly list areas of interest to the crypto forum, but maybe some areas in this space that that you're going to work on, or things that the crypto forum touch are directly impacted. So at the moment there are 4 open calls currently open. Visit ngi.eu for more information. I'm involved in the NGI Trust open call. There's one called Ledger for distributed ledger technologies, Zero Discovery from NONet Foundation, and Privacy Enhancing Technology, also from NONet Foundation. And so two of these open calls follow a similar path. If you swap up. The deadline for the NLNet Foundation calls are the 1st of April. That's pretty close. You're probably not going to make that unless you have a free weekend ahead. But these other open calls are open until the 30th of April. So people asked although this is a European initiative, it doesn't exclude the rest of the planet. There's actually these two specific projects, Explorers and Think Nexus, that are working on EU-US collaboration. All other participants need to be European or associated countries of Europe. So it's best to find a partner in Europe to work on your project with, unless you're already involved in these specific collaboration projects. And there'll be more during the lifetime of the NGI program to bring in more countries. Often Europe has specific calls with particular funding bodies in other countries to support this sort of initiative. But at the moment, only an EU-US program exists and one focused towards Europe and for the benefit of Europe. So it doesn't necessarily mean it has to be 100% European in the constitution of your team. Yep. So you can see this is a pipeline of NGI calls. Currently, 4 are open, and there's 3 that are the actual proposals to the EC close very soon now, so that there'll be coordinators for 3 more projects that will start later this year. And so the 2 in green are coordinated by InnoNet Foundation. I'm the mustard colored one. And there's a distributed ledger technology group. Swipe again. So the key characteristics of these, depending on how much money you want to get and how in-depth your projects are. So there's only 3 competitive calls out of my consortia. The first one ends 30th of April. We'll be running another open call window in October this year and February early next year. There's 3 categories of projects: viability, execution, and commercialization. So you can get up to 100,000 euros for the viability to do pilot and experimental work. Equally, InnoNet Foundation have a project where you can get between 5,000 and 50,000 euros for similar work. The execution stage is a co-financed a project, so you would have to provide or find funding of 90,000 euros to match the 180,000 euros that we would provide, and for the commercialization you would need to provide 200,000 euros of matching funding to match the 200,000 from this project. We don't take a stake in your business as a result of that, right? This is not tied to equity financing. Next one. And yeah, this is the other 2 projects, Search and Discovery, InnoNet Foundation, similar conditions but focused on a different area, and Ledger, distributed ledger technologies offering up to 200,000 euros and supporting the creation of a business out of the result of your ideas. If you want to contact me, do so. I can put you in touch with those that you need to talk to, or visit the ngi.eu website, look at open calls. Thank you.
Okay, thank you, Brooke. So seek out Brooke if you want more details or information on this call. Okay. Yeah. So we're going to move on now to the last planned presentation of the session. We are running a little bit behind, about 10 minutes, so we're going to steal some of your lunchtime. We think this is an important topic, so please stick around. But obviously, if you need to go, then please just leave, but please do so as unobtrusively as possible. And we're going to hand over now to Stanislav, who's going to talk about PAICS and the PAICS selection process.
Hello again, Stanislav Smishlev, and just a short disclaimer that it is not some result of some study, it's more of a potential starting point for our possible process with selecting PAIC. So in Bangkok, there was an announcement of a PAIC selection process, and after receiving some PAIC proposals, there was an initiative to announce PAIC selection process. The aim was to select 1 or more PAICs for usage in IETF protocols. There were some opinions, including the ones that it must be not 1+ but 0+ PAICs, that it's better to have 1 without a variety of options, and some parallels with previous process with elliptic curves. And there was a call for questions for each pack, so to understand which criteria should we apply to each pack. Because the main idea is that after we collect some number of criteria and some idea how to deal with this process, then the crypto review panel will help with assessing the security and the properties of each pack. So a very general scheme of a very typical pack, which is a balanced pack. It's 3 phases: key exchange with protection with passwords, so that the adversaries that can intercept and modify all messages cannot do anything better than just online guessing of password by some request to server or client. Then some key derivation phase and optional explicit key confirmation phase. We call a pack balanced pack if a server and client have the same password stored at their premises, and augmented pack if server side stores some transformation of password. So it can be used to protect against server compromise in some sense. So general questions. I know that this is most painful questions for all process, but I can't miss this. Should we select one pack for all applications? Can we select one size fits all pack, or should we understand some distinct set of requirements for packs and then try to find the one for each set? 2 simple examples here for augmentation property of a pack. It's great when a pack is augmented and moreover with security against attacks involving precomputations as OPAC. If we talk about client-server protocols, but if we are talking about protocols for messengers, for IoT, for Wi-Fi, DPP, for example, then the augmentation property is not desirable there, it's not needed there, but it adds some complexity. So it may be a question whether we need this property always. Second question here is about key confirmation stage. It's great and desirable when we talk about pack itself, when we use it as it is, but if we try to integrate it to some protocol which has its own key confirmation stage, it may be redundant to have 2 key confirmation stages, obviously. There is a great draft by Richard Barnes about usage of packs in TLS 1.3 with possible sets of desired properties for packs for usage with TLS, and examples of protocols that meet these requirements are in this draft. And of course, it will be great if we could understand such sets of requirements for each possible applications, for IPsec, for messengers, for M2M, for IoT, etc. Then about questions for each pack that were obtained during this call for questions. First of all, about the requirements of our RFC 8125, requirements for pack protocols by Jan Schmidt. It doesn't meet should requirements of this protocol, and what's with security assessment of this pack? Is security proof complete? Is it doesn't it have some questionable assumptions from the primitives? Does it allow to be sure that we are secure for typical password lengths? So are the security bounds okay? Is the pack okay for 2 primary IETF protocols, IQ2 and TLS handshake, based on the properties that are desirable for them, for the pack? Are there some non-trivial security properties that must be treated well when implementing a pack? For example, resistance against side channel attacks. What's with crypto agility and what's with performance? Then just a very quick overview of packs in CFRG. Starting from 2013, there were 9 packs discussed in CFRG. There are a lot more packs elsewhere, and sorry if I forgot your favorite pack here. And a very short overview of all packs. Dragonfly is a balanced pack that has now a security assessment that has its own RFC 8492, informative RFC of usage in TLS. In a nutshell, it's presented on the slide. It has two possible issues. First of all, it needs a method of deterministically mapping of passwords to elements of selected groups. And secondly, in the draft, in the RFC, it stated that an elliptic curve group must have a cofactor of 1. That is a requirement that can be a little tight. SPEC2 is a very solid and well-studied protocol. It's a balanced protocol, which is minimalistic in some sense. So it's only one key exchange in the one side. It has full security proof in this paper. There are some ongoing discussions on addressing cofactors in Diffie-Hellman in the list, but I believe that they will end soon because it doesn't seem to be a large problem. SPEC2 Plus is augmented version of SPEC2, so it has the same issues with addressing cofactors in Diffie-Hellman, but nothing very difficult. This protocol doesn't have its own security proof, but it's based on the ideas that are assessed in this paper. It's also addressed in the draft by Richard Barnes, so it's an augmented protocol that has some partial security proof that's augmented but not secure against precommutation attacks, which are addressed later in OPEC protocol. CSPEC is basically a protocol that is based on SPEC2 with several modifications, plus a key information stage and its separate security assessment. ELK-PEC is an augmented PEC that has security proof but has some issues with this. So security proof is incomplete. There are some issues with security bound. So if we look at the ELK-PEC more thoroughly, then the security proof issues needs to be repaired. One more issue here is that pressured key is generated by one side, so it's more like a key transport PEC, not a key agreement PEC. In a nutshell, it's on the slide. JPEG is a completely different protocol. It's based on zero knowledge proof. It doesn't have anything in common with any other PECs in consideration. It has its own security proof. It's good, it's solid, but it requires more computations. It doesn't require trusted setup, but the computations are quite complex here. In a nutshell, there's on the slide, but I believe that nothing can be understood even in this nutshell representation. PKEX is a protocol that is defined in a draft by Dan Hawkins. It's a balanced PEC with two phases. The first phase is based on SPEC protocol, basically, and the second phase is a very interesting phase that provides an ability to bind the identities to public keys, and using this idea, it provides some good mechanisms to provide privacy. In a nutshell, it's SPEC2 plus additional phase. It doesn't have its own security proof. Its first half is based on SPEC2 with security proof, but PKEX doesn't have its own security proof. And one issue here is that the discrete logarithms of public role-specific elements must be computationally infeasible. It's critical for the security protocol. The same applies to SPEC2 and CSPEC that were announced in the previous slides. TBPECI and VTBPECI are two protocols based on SPECI protocol. It's a generalization of SPECI to arbitrary cyclic groups, for example, for a group of points of elliptic curve. In a nutshell, it's on the slide, and it has its own security proof for all, balanced and augmented version. And VTBPECI is an augmented version. We don't have a draft for this protocol in IETF, but it was presented about 3 meetings ago at CFRG. But it is not secure against precomputation attacks, in contrast with OPEC. OPEC is an augmented PEC, secure against precomputations with good and complete security proof. It's more like a way of compiling any secure key information impersonation secure authenticated key exchange to an augmented PEG using oblivious PRF. So we take secure oblivious PRF, secure authenticated key exchange, and can obtain augmented PEG. It has its own security proof. The proof is modular, so it applies to any composition of any good oblivious PRF and any KCI secure key exchange. It has two phases. In a nutshell, the first phase is registration phase, when a key pair is submitted using a secret obtained from oblivious PRF using password, and then authentication phase, when the envelope is obtained from the server and then used for authenticated key exchange. And we have a great draft by Nick Sullivan of usage of OPEC with TLS 1.3 that was presented yesterday at TLS working group session. Then very short about PEG requirements and these protocols. So requirement one is about balanced versus augmented. For all these protocols, it's clear. Only Spec2 Plus, OPEC, VTB PEG, and OPEC are augmented, and only OPEC has an additional security against precomputation attacks. It's more difficult about security assumptions, security assessments. It must be noticed that, of course, all this yes and no must be verified by crypto review panel if we move on with this process. But to be short, for most PEGs, there are some kind of security proofs. For some of them, they are partial, or as Kravchik said, no security proof for someone. For PKEX, we don't have any security proof. And for all augmented PEGs, except OPEC, we have security proofs with model that is weaker than proposed for OPEC. For other requirements, they are more about the document, not about the PEG itself. So it's about the next slide. When we select one or more PEGs, we should do something with the next steps, what we should do with the documents in CFRG. If you create a new CFRG document for these PEGs or just recommendations usage with additional blessing by CFRG, in any case, we must address implementation issues, because security models for PEGs are quite difficult and quite different from what we have for typical key exchanges. For example, these three protocols, PEGs, CSPEC, and PKEX, require trusted setup, that discrete algorithms must be unknown, otherwise backdoors or bugs can be there. And resistance for side-channel attacks must be addressed. So, to conclude, three key questions to consider. We have several PEGs, we have some criteria to compare from, and we can give some recommendations for usage protocols. The questions are suggestions to add remove some PEGs from the list of candidates, to add remove criteria, and what else should we address. Again, a disclaimer that it's not a result of some study, it's more like an overview to push forward the process of selecting a PEG. Thank you. Watson?
Thank you. Let me just, before we jump into questions, just say that we're already somewhat behind schedule, so we'll try and maybe have, well, 5, maybe 10 minutes max of Q&A now and discussion. Before we get into that, let me say thank you on behalf of the chairs to Stanislav for putting together this really excellent and detailed presentation. We got a lot more than we paid for, so thank you very much.
Thank you.
Okay.
So I'm Watson Ladd. In case people don't know, I'm the author of one of the PEG drafts. I don't want to go into the details of the comparing the various PEGs here. I think we can do that more productively on the list. I do want to say that there are existing applications, and we should take this into account. Magic Wormhole definitely belongs on the list of examples where a balanced PEG is needed. Mm-hmm. That's certainly the real question I want to ask here is more procedural, and is the idea that we're only going to publish one of the ones that's a draft, and we're not going to select others. We've had a very bad history in the CFRG with a contest-like thing. Contests are not something the IETF is good at. I'll feel a little more comfortable if this was about assessment and sort of here's the list of properties and we look at and sort of this is what we think protocols should use rather than there can only be one sort of thing.
Thank you for the comment. Yes, I agree with most part of this.
Dan Harkins, thank you for this. Regarding number one, I think we could remove PKEX from the list of candidates because it's not really a raw peg. It's kind of a composite. The point is to kind of parlay a shared secret into a trusted public key, and the result is a trusted public key exchange. And it's not really, it's different than all the other ones. And I think if we want a balanced peg or an augmented peg, PKEX isn't even in the running for that selection. Thank you.
Chris Wood, I have a question for the chairs, and I apologize if I missed it. What is the effect of this whole peg selection process on the existing drafts that are going through either individual drafts or research group adoption? So for example, OPAKE and SPAKE2, are they going to move forward alongside the peg selection process, or are we trying to potentially gate them on something like this?
So with SPAC, it predates the process, so we're already sort of committed to doing it, which put us in very interesting position. I think that any other is not really, well, we also have OCPAC, which is expired, but anything else is not accepted by, not adopted by CFRG yet. So hopefully we can narrow down on comparison first, and then we'll adopt whatever matches, or, you know, maybe a couple, and then, you know, try to figure out whether we can get down to one or whatever, you know.
Okay.
So I'm not quite committing to exact course of action, but I'm trying to explain the thought process.
Yeah, okay, I get it. Thank you.
Hannes?
Yeah, I think in general, it's fair to say that the bakes have been tremendously unsuccessful in deployments. There has been recent interest, again, renewed interest from IoT environments. And so I would also suggest to, as you do your assessment, to reach out to some of those communities, because there seems to be some interest there, because people are using those for onboarding and have maybe additional requirements. And one other aspect to take into account, because we are already a few years into this bake discussion already, is to take some of the deployment status into account, because, for example, we had to implement stuff, and now if like things bubble up, and it's not so nice to just randomly implement other things, and then people change their mind on a regular basis, so it gets a little annoying.
Yep, thanks for that. Please do contribute as much as you can, Hannes, to the mailing list discussions, and keep us updated on, particularly on deployment. We really understand.
Okay, Guilin Wang, yeah, from Huawei International. Yeah, first thanks for the initial comparison.
Come closer to the mic.
Yeah, okay, sorry.
Yeah.
So, yeah, very nice comparison already, but of course, still a lot of technical issues probably need to be discussed in more detail, but this can be done later, of course. My main question is that, shall we have some lesson like a more specific schedule, I mean, time deadlines or something, or a little bit more relaxable? I don't know. Yeah.
So chairs need to discuss exactly how we're going to do this. I think we're acutely conscious that when we did all of the work on elliptic curves, it was very energy sapping, and we would like to avoid that kind of situation again. So hopefully this may prove less demanding and controversial than the elliptic curve, but clearly we need to put together some kind of process and schedule here. So the chairs will work on that and get back to the research group with a proposal for how to move it forward.
Okay, I appreciate it. Yeah, thank you.
Yavnir, and there's definitely interest in the IPSA community to have a way to log into the VPN with a password that's better than what we're doing now, because what we're doing now is IKE version 1 with the Cisco extension AXOth, which is worse than any kind of fake that you add. And any fake is an improvement over that. So yeah, there is interest.
A small comment. If it's possible to provide some ideas like this one from IPSec working group, I think it will be very convenient. If you can have some kind of properties that is desirable from the viewpoint of IPSec working group, if possible.
So we actually did we talked about this already in the IPSec working group, and the main concern was that we need augmented pig, because we have like like equal peers. We don't have sort of client servers. So so that was the main requirement from our end.
Thank you.
Joe Salloway. In the TLS working group, we've had presentations on PAICs and some discussions, but we really have never had a groundswell of, this is a specific use case that everybody agrees on needs to be solved with a PAIC. So there's interest, but not, it's not necessarily something that's driven through the working group right now. Perhaps if there was a PAIC that would come up, but I don't think we have a set of requirements that are working group requirements.
Joe, just while you're there, has the working group, TLS working group, adopted any of the any drafts in this area?
No.
Just
we did a long time ago, and then it never made it out because there was not necessarily agreement on a number of things.
Ben Kaduk, in the Kitten working group, we adopted a draft to use SPAIC. And we chose it because it was balanced and because it had the low message count, one message each way. We chose balanced because we have to cooperate with other authentication mechanisms that are already in use. If we had greenfield deployments, then we could have used augmented PAIC instead. And that draft is actually submitted to the ISG for publication.
Valery Smyslov, LS Plus. I wanted that IPsec working group in IQ2 even have RFC that defines a generic framework for integrated any PAIC scheme into IQ2. Unfortunately, it is not used. It is not widely used as far as I know, but there is already an RFC that allows to integrate any PAIC to IQ2, any generic PAIC scheme to IQ2.
Okay, any other comments or questions on or suggestions on PAICs? Okay, then Alexei will say something about what happens next.
Thank you.
Or I will. So chairs, we need to get together and work with some of the key people here and figure out what the process and the timeline should be. So look out for more information on the mailing list soon about that. We hear the demand. We see the different sets of requirements that people have. And so obviously we'll keep those things in mind as we move forward. So thank you everybody for your contributions, and hopefully this will be a fun selection process for everyone concerned. Okay, and I think that's the end of CFRG. So thank you for indulging us with some of your lunchtime. Thanks a lot. And can we have the blue sheets back, please? There's one floating around somewhere. Thanks.
Hello, Christian. I want to thank again for yesterday's question, and for the link I will read and update my document according to the analysis.